Now, if we just look at this slide a bit and we think about what are the global patterns of average temperature, these are just average annual temperatures in different parts of the world. What are the patterns? And the first one you knew before you ever took this class. The tropics are hotter than the places outside the tropic, especially hotter than the middle and upper latitudes. So you know that already. We call that latitude. And that's the most significant one of all of the patterns of global temperature. There is another one, though, that's also apparent here if you look a little bit. And maybe the easiest place to see its influence is by looking at South America. So go down to South America to the tip there, off to the left. That's the lowest continent there to the left, other than Antarctica itself in the extreme bottom part. Look along, there's this whole area of green where the average temperature then would say be 40-ish degrees or so. And if you look at that, why would you have, even in the same latitudes, even near the equator, near the middle of the map, you'd have much colder temperature? What's going on there? The answer? Mountains. So the second factor is elevation. The other factors, I'm going to click to the next slide. I got to go back and see whether you actually can see it when I click. I'm not sure that you can or can't, but I'm going to give it a try here. In any case, you've got your regular printout of notes. So we have these others, and these are all ones you want to be familiar with for the test and understand pretty well. So the next ones are, we've already done latitude, we did altitude, the basic relationship, the higher it is, the lower the annual average. Winds and ocean currents. Now later you're going to want to go see this, but the basic point here to think about is if you look at, say, the Atlantic Ocean basin off the eastern United States, okay, and east of Mexico, toward the right, in other words, on a map, you'll see there's this very warm current, and it's called the Gulf Stream, and it is a current which brings very warm water way up to the north, as we've mentioned a little bit before, and that current moderates then in the end northern Europe, making it warmer, and the winds off that warm current bring in that warmer air into northern Europe. So winds and ocean currents operate together, and that would be the example I would want you to offer on an exam if I asked you, okay, give me an example of the winds and ocean currents. So it's the Gulf Stream, and later you have a map that shows this, and then that warm North Atlantic drift going off near Europe, and then the winds blowing over that carry that warm air above the current off to the European continent, making it warmer, making the growing seasons longer, and so on. Continentality is all about the range of temperature in places, giant continents like Asia. You have huge range of temperatures because land cools off really rapidly and warms more quickly than water. We noted that already, that land is much less stable in temperature. And continental is just a measure of that. Later, we'll see a slide that shows the area of Siberia with a 100-degree Fahrenheit annual temperature range. Pretty amazing. Local effects include things like surface albedo or reflectivity. So if you're on an ice sheet, not only is the ice keeping it cold, but it's reflecting back almost all the solar radiation. So you end up with a cool climate because of that. Now, one of the interesting things that's happening is aerosols, ash, dust, and so on, are being deposited on the global ice sheets, especially in Greenland. We're seeing this, and the somewhat darker color now that happens to the very surface of the ice on Greenland. What do you suppose would be the effect on albedo? A little darker surface, it's going to be less reflective, isn't it? What would happen then to the rate of ice melting when that happens? Not hard to figure it out, right? It's a little darker, it's going to absorb more solar radiation and melt even faster. Aspect is another one, and north slopes facing to the north, away from the sun in the winter. If you think about where the winter sun is in the middle of the day, that's south in this part of the world. Just the opposite direction of that is north. So if you put your back to the sun, you're looking north. And north slopes are cooler than south slopes in the northern hemisphere. In the southern hemisphere, it's just the opposite. And then finally, cloud cover. What is the effect of cloud cover? Areas that have constant or frequent cloud cover in a particular time of year tend to be moderate in temperature. That does tend to keep the extremes away. Not quite as hot on the extreme and not quite as cool on the extreme on the cold end either. So cloud cover just moderates temperature range during the day and even somewhat during the seasons. That's one of the reasons the Oregon coast, aside from the water also there, of course, is a bit more moderate in the summertime. It's cooler and somewhat warmer on average in the winter than, say, the Willamette Valley or even more so eastern Oregon.